More and more developers are opting to choose AWS Lambda for their workloads. But if you're not careful, there's a bunch of traps that you can fall into that could end up costing you. And in this video, I want to talk about my top pitfalls when working with AWS Lambda. So let's get into it. All right, so for number one, I want to talk about Lambda overloading. This is one that I'm personally guilty of, and this is the idea that we overload a single Lambda function with multiple different responsibilities. Now, say for example, we have a function that we hook up to an API gateway endpoint to serve as a REST API. Then we use that same function and hook it up to an SQS queue to act as an event processor. This one Lambda function is serving two different purposes, which isn't ideal for a whole bunch of reasons. The first reason is that both of these different workloads can scale independently and require different memory configurations. So maybe in your SQS processing, you're pulling in a whole bunch of data, or you want to pull in a whole bunch of different messages. You may need a lot more memory provisioned on a Lambda function with that workload compared to maybe a REST API where it's just fetching a single record from a database and giving it back. So it becomes challenging to set the right configuration parameters if you overload a function with too many responsibilities. The second key one is the fact that monitoring becomes challenging. This is again because we have two different independent actions going on in this Lambda function. So if your latency seems to be spiking on your function, is it because of the SQS half of the equation or the API half of the equation? You're going to have to do a lot more digging into the issue to really understand at face value what is actually going on. Now, the right way to do this is to have two separate Lambda functions. That way you can set up different alarms, you can monitor the metrics separately, and you can tune the functions with the right memory setting that is right for their workloads. My second major pitfall is using the CloudWatch put metric API. This is a really common one, and most people don't realize that metric filters exist. So it's very common to want to collect metrics in your Lambda functions. Say maybe you want to collect counters on the number of times you're calling a dependency or the amount of latency that it's taking to call that dependency. Many folks try and find, how do I put this data into CloudWatch? And they look at the put metric API in the CloudWatch service. This service requires you to make an HTTP request to call the CloudWatch service to synchronously put your metrics into CloudWatch itself. This isn't ideal because, as we know, Lambda is billed by duration. So every extra millisecond that your Lambda function is spent processing, in this case by writing to CloudWatch, that's extra money that you have to spend and gets added to your bill. Obviously not ideal. Now, there's a much better way to do this using CloudWatch metric filters. And this is the idea that instead of putting your metrics into CloudWatch, you simply emit a log line. And within that log line, you emit the name of the metric and the number of counters that you wish to pair with that metric. So say, for example, you want to count the number of exceptions you get when calling a dependency. You may put something like a legal argument exception equals to 1. And then when you set up a metric filter, you specify a rule, which is kind of like a regular expression, which can be used to parse that format that you wrote and put that data into CloudWatch. Much more efficient. It all happens offline, so it's not a part of your Lambda function invocation itself, but something that happens by parsing the log lines that you emit to CloudWatch. The third one is chaining Lambda functions synchronously. And similar to the other one, this has some cost implications for you. So many people write a Lambda function, then they have another Lambda function that the first one needs to call. So there's one hop there. Then that second Lambda function needs to call another Lambda function, so on and so forth. This can happen many, many times. And if you're using synchronous Lambda invocations, as a reminder, synchronous just means you make a request and you wait for the response. That means that your first request is going to wait for the second to resolve, and the second request from the second Lambda function is going to wait for the third, so on and so forth. So what you end up getting is stacking duration that ends up costing you a lot more if you were to use something like asynchronous processing, or maybe hooking up your Lambda function to a queue and moving your messages along that way. This is something that you should avoid, and it sets us up nicely for our fourth pitfall. The fourth pitfall is using Lambda functions as an orchestrator. And a lot of people combine this using SQS and Lambda functions because it's an easy way to move messages around from your Lambda function and letting the output of one function be the input to another based on the message that's in your SQS queue. Now, the reason that this is bad is because it becomes very, very challenging for you to analyze what is actually going on in your application when your data is bouncing around between many different Lambda functions. As we know, log streams are independent to the Lambda function, so it could be difficult to pair all the logs that are related to a particular invocation. What you should consider instead as an alternative to this approach is to use something like step functions. Step functions allow you to build a workflow within AWS, and it allows you to integrate with AWS Lambda as well. Allows you to do things like fallbacks and error handling and automatic retries. It's very easy to analyze what happened in a step function workflow through the AWS step function console, because it gives you a really great visualization of which steps the flow is going through, where failures occur, where successes occur, and the input and output as it passes through the graph. Very, very handy. I have a whole bunch of videos on step functions that you should check out. It's hands down one of my favorite services on AWS. And my last pitfall for you is not using batch processing when using SQS and Lambda functions for event processing workloads. And the idea here is that when you have a message inside of your SQS queue, you can set it up so that you invoke your Lambda function with a single message. And as you can imagine, if you have many, many messages, this is many, many different invocations that are going to your Lambda function. Now, there's a much more ideal way to do this, which is to use SQS and Lambda batch processing. This tells Lambda to pull multiple SQS messages at once and pass all of those records into the event body in your Lambda function invocation. This way, you can just simply iterate over all the different SQS messages in the input and process them independently. Now, you do have to be careful when you're using this approach because there are partial failures that can occur. And when failures occur, you want to put those failed messages back into the queue to possibly retry for later. Now, there is an easy way to do this using failure reporting. So you can return out of your Lambda function invocation a list of SQS message IDs that failed, and that'll indicate to SQS to put those messages back into the queue, and the ones that you successfully processed will be deleted so that they're not going to be repeat invocations with the same message for next time. So those are my top Lambda pitfalls. If you enjoyed this, check out my other ones on AWS Lambda to the left and right. And thanks so much for watching. I'll see you next time.